Hi students, this chapter we are going to look at energy changes. Okay, so all your chemical reactions will involve energy, and the particular energy that we are interested in is heat energy. Okay, so we have two terms that used to describe energy changes in a chemical reaction. Number one, exothermic and endothermic. So thermic comes from the word thermal. So exo is giving out heat energy, and then endo is taking in energy. Okay, so exothermic, you can see that this heat energy is radiated out from the surrounding. If you touch the test tube, you will feel hot. And then endothermic, my energy is being absorbed in, right? And then if you touch the test tube, you will feel cooler. Okay, we also use bond breaking and bond forming, as well as energy profile diagram, energy level diagram to describe these two types of reactions, and we will look at it a little bit in detail in the next few parts. Okay, so exothermic and endothermic. Right, as I was saying, exo is giving out heat energy, endo is taking in heat energy. So exothermic reaction is where heat energy is given out and the temperature of this surrounding will feel hot. Okay, there's an increase in temperature. This surrounding, it will feel hot. If your thermometer will detect a rise in temperature. Okay, and then endothermic, the temperature of the surrounding will decrease and you will feel it cold. The thermometer will detect a drop in temperature. Okay, energy of these reactants decreases. Okay, so imagine the reaction is reacting and it gives out the energy. So this energy will decrease, the surrounding will increase. Okay, and then same thing over here, because this is your reactant and products, and then they absorb the energy, endothermic. So they absorb in the energy, this will increase, but your surrounding area, right, it will detect a lower temperature. So energy of the products will increase in your endothermic reaction. Okay, and this temperature graph is the temperature of the surroundings. So exothermic, you can see that the temperature will increase, and ultimately, after some time, your reaction will come back to room temperature. Endothermic, because it is absorbed in, right, the temperature of the surrounding will decrease because this energy goes into the reactant, and it will decrease, and then it will go back to normal room temperature after a while. Okay, so examples of your chemical reactions. This one I would say mostly is memory work. Remember as many as you can. Okay, combustion reaction, burning. Right, when you see this word combustion, this is burning, and oxygen is always your product. Okay, so when I burn something, it produces the flame. This flame is the product of combustion, and energy is given out because of the flame. Okay, thermal decomposition. So decompose is one substance breakdown into a few other substances. So I want to break something down, I have to absorb in this energy and use this energy to break it down. Okay, so energy is being absorbed to break down, and all decomposition reactions are endothermic, absorbing the energy. Okay, other common examples will include respiration. Right, I take in oxygen, and the food that we eat, it gives out carbon dioxide and water, but energy is produced for us to continue to do our daily life. Okay, another example, photosynthesis. This is absorbing energy. Plants absorb sunlight and produce food. Right, so this is endothermic. Okay, neutralization reaction with acid bases. I tell you many times, if you touch the test tube of acid alkali, you will feel hot, exothermic. And then action of light on silver bromide. So light is being absorbed from the silver bromide to form Ag plus Br2. Okay, and that's where my film will develop an image. Okay, and this is light energy being absorbed in. Okay, dissolving substance, this is dissolving anhydrous sodium carbonate. Dissolving dry sodium carbonate and sodium hydroxide. This is exothermic. And then dissolving ionic compounds. Okay, all your ionic compounds, and especially the ammonium compounds over here, this one we have to remember. Whenever you see ammonium something, you touch the test tube, it will feel a little bit cold. Endothermic. Okay, why is dissolving endothermic? Because there's large amount of energy absorbed. So when I absorb in, it will be endothermic, right? And this energy that's absorbed is used to break the strong electrostatic force of attraction of my ionic compound. Okay, dissolving concentrated acids, this is exothermic. And then rusting, metals with acid reaction, metals with chlorine reaction. EFG, good to know. Okay, these are all exothermic. And then condensation, freezing. These are physical processes. Okay, why is it exothermic? Okay, condensation, this is my gas turns liquid. So gas is random and far apart. High energy, they are moving at high energy, high kinetic energy. And then they start to come closer and slide in layers. So high energy fast becomes slower sliding in layers. So what happens? This energy is given out to the surrounding, exothermic. Okay, on the reverse side, if I have melting and boiling, for example, right, liquid turn gas. So from sliding in layer becomes far apart. Right, liquid sliding in layers not as much energy as gas moving random and far apart. So what happens? This energy is absorbed in. When I absorb in, I break the attraction force. Then your liquid can turn into gas and they start to move faster.